Hello everyone. I hope you're all doing well. This channel delivers videos that promote the importance of mathematical modeling techniques. In the previous video, I classified natural numbers and defined the Collatz operations based on the differences in how their calculated values change under the Collatz process. In this video, I will show that the entire process in which the calculated value evolves from its initial value down to 1 can be fully described using these Collatz operations. As shown in the previous video, when we follow the calculation algorithm of the Collatz conjecture, odd numbers can be divided into two categories: high-quality odd numbers A and low-quality odd numbers B. A high-quality odd number is defined as follows. If the initial odd number is n sub I, then the even number n sub I plus 1, obtained from the calculation 3 times n sub I plus 1, when divided by 2, yields n sub I plus 2, which is also an even number. Conversely, a low-quality odd number is one for which n sub I plus 2 becomes an odd number. High-quality odd numbers can be further divided into two subcategories. If the calculated value, n sub I plus 3, is an odd number, we define it as a good quality odd number and denote it by a prime. On the other hand, if n sub I plus 3 is an even number, we define it as a better quality odd number and denote it by a double prime. Even numbers are not subdivided and are simply denoted by C. Using the classified natural numbers described above, we define each unit of calculation as a Collatz operation. Accordingly, when a natural number is of type A, B, or C, the corresponding calculations are called Collatz operation A, Collatz operation B, and Collatz operation C, respectively. Collatz operation A represents the calculation process from n sub I to n sub I plus 3. Collatz operation B represents the calculation process from n sub I to n sub I plus 2. The calculation process of Collatz operation C consists of n sub I and n sub I plus 1. Furthermore, each Collatz operation is classified into a Collatz operation type according to whether its final number is of type A, B, or C. Since high-quality odd numbers of type A are further divided into good quality odd numbers A prime and better quality odd numbers A double prime, the types of Collatz operation A are distinguished accordingly. A Collatz operation type is expressed by placing an arrow between the types of the natural numbers at the beginning and at the end of the calculation. For example, in the case of a prime arrow a prime, we can see that both the initial value n sub I and the final value n sub I plus 3 are good quality odd numbers. In the case of a prime arrow B, the initial value n sub I is a good quality odd number, while the final value n sub I plus 3 is a low quality odd number. Next, in the case of B a prime, the initial value n sub I is a low quality odd number, while the final value n sub I plus 2 is a good quality odd number. Similarly, in the case of BB, both the initial value n sub I and the final value n sub I plus 2 are low quality odd numbers. In the case of C arrow A prime, the initial value n sub I is an even number, and the final value, that is, the next value n sub I plus 1, is a good quality odd number. In the case of C arrow a double prime, the initial value n sub I is an even number, and the final value n sub I plus 1 is a better quality odd number. In the case of C arrow C, both n sub I and n sub I plus 1 are even numbers. Now, let us assign the Collatz operations a prime, a double prime, b, and c to the sequence of calculated values that appear when the initial value n sub 0 is set to 27. The natural number 27 is a temporarily explosive number. Its calculated values increase rapidly for a while, reach a maximum value of 9,232, then begin to decrease and eventually reach 1. The results of this assignment are shown in the following table. The changes in the calculated values can be completely represented using the 4 types of Collatz operations. Among them, Collatz operation C appears most frequently, followed by Collatz operation B. If we include Collatz operation a double prime, which directly leads into Collatz operation C, we can see that the proportion of operations that reduce the magnitude of the number is quite large. The following figure shows how the calculated values change in the iterative calculation when the initial value is n sub 0 is equal to 1,10,101,010,101. In this case, the calculated value reaches its maximum at the very first calculation, and after that, while repeatedly making small upward and downward fluctuations, it steadily decreases and eventually reaches 1. All of the calculated values are listed in the following table. As in the previous example, the changes in these calculated values can be completely assigned to the 4 types of Collatz operations without omission. As explained in the previous video, all natural numbers can be classified based on the differences in the types of values that constitute the 4 Collatz operations. Therefore, it is clear that the type assignment shown here can be applied to the calculated values generated from any natural number used as the initial value. From these observations, it may appear at first glance that the calculated values in the Collatz conjecture could be predictable, but in reality they are not. This figure shows how the calculated values change when the initial values are the high-quality odd numbers 17, 49, and 81. The first and second sequences correspond to values that also appear in the iterative calculation with the initial value n sub 0 is equal to 1,010,101,010,101. The third sequence, except for the very first number 81, corresponds to values that appear in the iterative calculation with n sub 0 is equal to 27. Although all 3 sequences begin with the same pattern of Collatz operations, a prime, a double prime, and C, in that order, their subsequent behavior becomes completely different. Furthermore, the number of iterations required for the calculated values to reach 1 also differs among them. This indicates that the behavior of the calculated values in the Collatz conjecture can vary drastically depending on the initial value. When we view the changes in the calculated values from the perspective of Collatz operations, we can predict what type of natural number will appear next whenever Collatz operation a prime, a double prime, or B is executed. However, when Collatz operation C appears, it becomes impossible to estimate how many times it will continue, and the prediction breaks down at that point. This suggests that the changes in the calculated values for all natural numbers cannot be expressed in a unified manner by a single equation. That concludes today's talk. I look forward to seeing you again in the next video. Until then, take care.